So you are asking me that how different gaseous particles, other particles in the out there, they become concentrated. How it is happening, right? So that's the question. Now, suppose this is a region of space where there are particles equidistant from each other. This region may be inside some cloud forming region or something. So all the particles are equidistant to each other. Now this picture is very unrealistic. Why? Because I didn't say that these particles are at absolute zero temperature. They must have some finite temperature. This means they must have some random motion. They must be moving around. Okay. But even though they are moving around, they are still equidistant to each other. So overall, the system is more or less symmetric. Highly symmetric, you will say. Now, star formation or some structure formation will never happen. Why? What is the signal? Suppose this is y-axis, this is x-axis. Okay, this is time. You are observing something and this is counts. And you are observing just like this. So what will you say? Will you say that, sir, I am observing something different? Will you say? In a way you can say, because this is not zero. But I am asking you, you are observing for a very large time. Okay, very large time. And you are still seeing a sort of average. Will you say that I am observing some signal? No. But if you observe something like this, then you will say, okay, I observed some signal at this particular time. Same here. I am talking about formation of a structure, whether it is a star, whether it is something, planet, whatever. So formation of a structure means there will be some sort of conglomeration, some sort of compactness somewhere. So this means that if things are equal out there, then for star formation someone needs to be deprived of and some place needs to be conglomerated. Some place must be densely packed. Otherwise there will be no such thing like genes, star formation. We talked about genes mass. So this needs some sort of what? Density, compactness. They must increase, density must increase. If they are equally apart from each other, then this situation is similar to like this. No structure will form. So, but we need a signal or a structure formation. For that, what will happen is that during the course of the universe, it is never like this. There will always be some sort of disturbance out there. Some sort of disturbance. It is always there. And because of this disturbance, say from here, some sort of shock wave comes. This I talked about during genes. What?
Genes mass.
Genes criteria, even before that. Genes instability. I talked about it. Remember? So because of this, what will happen? This will go closer to this one, this will go closer to this one. And the second picture you will see is something like this. So even though the space was like this, now they are closer to each other. So you can say that out of all this space, the gas particles have become closed enough. Okay, so there is a sort of asymmetry. So because of this disturbance, there is a sort of asymmetry, and it is this asymmetry which has resulted in structure formation. This is very important. Some reason, some particle is coming, some meteorite, some comet, some supernova explosion, huge burst, some sort of structure is there. Even the Big Bang, it also resulted due to some instability, some disturbance. Right? We don't know the reason yet. But remember this thing. If there is no asymmetry, there will be no structure formation. In fact, the Kobe satellite has found, I don't remember, the asymmetry is around 1 in 50,000 or so in the entire universe. So very slight asymmetry is there, and that is sufficient for star formation, for structure formation. Now you understand? The presence of asymmetry is a very important criteria, and this is often missed in astrophysics. So students, you must remember that it is asymmetry which plays the most central role. Yes? Okay. Okay. So asymmetry. Okay? Now they start coming close to each other, then there will be contraction and all that, and then there will be fusion and all that. But this will never have happened if there was no disturbance, if there was no asymmetry to begin with. So importance of asymmetry is what I am trying to convey. Any more questions? Ask me. Structure formation will never be possible. You see, the signal being transmitted, the signal is above some sort of background. Again, this is our asymmetry, you can say, and this is the symmetric structure. And we always give importance to this signal, okay? The similar like that, the importance of asymmetry. Maybe it was God who created the disturbance, maybe some other thing, I don't know, we don't know. Maybe the result of some process which we still do not know. Maybe result of some force, fifth force, which we do not know. Maybe some form of dark matter, some manifestation, some physics related issue, which we still do not know. So there are so many things we do not know. Okay, but we know that it is asymmetry till now, which we know that has played the role in structure formation. So, role of asymmetry in structure formation. Any more questions?